Hello guys and welcome to my channel. In this session, we want to talk about life cycle approaches and we want to talk about what is the best approach for your organization, team, or your project. Well, if you want to find out more about this, then don't miss this training session. And as always, have a good one. Various life cycle models, such as the waterfall, spiral, and V, are useful in defining the start, stop, and process activities appropriate to the life cycle stages. Graphical representations of life cycle stages tend to be linear, but this hides the true incremental, iterative, and recursive nature of the underlying processes. The approaches that follow imply full freedom to choose a development model and are not restricted to sequential methods. Too often, the system definition is viewed as a linear, sequential, single pass through the processes. However, valuable information and insight need to be exchanged between the processes in order to ensure a good system definition that effectively and efficiently meets the mission or business needs. The application of iteration and recursion to the lifecycle processes with the appropriate feedback loops helps to ensure communication that accounts for ongoing learning and decisions. This facilitates the incorporation of learning from further analysis and process application as the technical solution evolves. Below figure shows an illustration of iteration and recursion of the processes. Iteration is a repeated application of an interaction between two or more processes at a given level in the system structure or hierarchy. Iteration is needed to accommodate stakeholder decisions and evolving understanding, account for architectural decisions or constraints, and resolve traits for affordability, adaptability, feasibility, resilience, and etc. Although the figure only shows a subset of the lifecycle technical processes, there can be iteration between any of the processes. For example, there is often iteration between system requirements definition and architecture definition. In this case, there is a concurrent application of the processes with iteration between them, where the evolving system requirements help to shape the architecture through identified constraints and functional and quality requirements. The architecture traits, in turn, may identify requirements that are not feasible, driving further requirements analysis with traits that change some requirements. Likewise, the design definition could identify the need to reconsider decisions and traits in the requirements definition or architecture definition processes. Any of these can invoke additional application of the system analysis and decision management processes. Recursion is the repeated application of and interaction of processes at successive levels in the system structure. The technical processes are expected to be recursively applied for each successive level of the system structure until the level is reached where the decision is made to make, buy, or reuse a system element. During the recursive application of the processes, the outputs at one level become inputs for the next successive level, or below for system definition, above for system realization. On projects where it is necessary to coordinate large teams of people working in multiple companies, sequential approaches provide an underlying framework to provide discipline to the lifecycle processes. Sequential methods are characterized by a systematic approach that adheres to specified processes as the system moves through a series of representations from requirements through design to finished product. A specific attention is given to the completeness of documentation, traceability from requirements, and verification of each representation after the fact. The strengths of sequential methods are predictability, stability, repeatability, and high assurance. While process improvement focuses on increasing process capability through standardization, measurement, and control. These methods rely on the master plans to anchor their processes and provide project wide communication. Well, historical data is usually carefully collected and maintained as inputs to future planning to make projections more accurate. Safety critical products can only meet modern certification standards by following a thorough documented set of plans and specifications. Well, such standards mandate a strict adherence to process and specified documentation to achieve safety or security. However, unprecedented projects or projects with a high rate of unforeseeable change, poor predictability, and a lack of stability often degrade, and a project may incur significant costs trying to keep documentation and plans up to date. The V model introduced in Forsberg and Moose described in Forsberg et al. And shown in below figure is a sequential method used to visualize various key areas for SE focus, particularly during the concept and development stages. The V highlights the need for continuous validation with the stakeholders, the need to define verification plans during requirements development, and the importance of continuous risk and opportunity assessment. The V model provides a useful illustration of the SE activities during the life cycle stages. In this version of the V model, time and system maturity proceed from left to right. The core of the V, that is, those products that have been placed under configuration control, depicts the evolving baseline from stakeholder requirements agreement to identification of a system concept to definition of elements that will comprise the final system. With time moving to the right, the evolving baseline defines the left side of the core of the V, as shown in the shaded portion of the below figure. A key attribute of the V model is that time and maturity move from the left to the right across the diagram, as shown in below figure. At any instant of time, the development team then can move their perspective only along the vertical arrow from the highest level of the system requirements down to the lowest level of detail. The off-core opportunity and risk management investigations going downward are addressing development options to provide assurance that the baseline performance being considered can indeed be achieved and to initiate alternate concept study at the lower levels of detail to determine the best approach. Well, these downward off-core investigations and development efforts are entirely under control of the development team. On the other hand, the essential upward off-core stakeholder discussions in process validation ensure that the proposed baselines are acceptable to management, customer, user, and other stakeholders. Changes to enhance system performance or to reduce risk or cost are welcome for consideration, but these must go through formal change control, since others outside the development team may be building on previously defined and released design decisions. The power of understanding the significance of the off-course studies is illustrated in NASA JPL report. As entities are implemented, verified, and integrated, the right side of the core of the V is executed. Below figure illustrates the evolving baseline as system elements are integrated and verified. Since one can never go backward in time, all iterations in the V are performed on the vertical time now line. Upward iterations involve the stakeholders and are in process validation activities that ensure that the proposed baselines are acceptable. The downward vertical iterations are the essential off-core opportunity and risk management investigations and actions. In each stage of the system lifecycle, the SE processes iterate to ensure that a concept or design is feasible and that the stakeholders remain supportive of the solution as it evolves. Incremental and iterative development methods have been in use since the 1960s. They represent a practical and useful approach that allows a project to provide an initial capability followed by successive deliveries to reach the desired SOI. The goal is to provide rapid value and responsiveness. The IID approach is used when the requirements are unclear from the beginning or the stakeholder wishes to hold the SOI open to the possibilities of inserting new technology. Based on an initial set of assumptions, a candidate SOI is developed and then assessed to determine if it meets the stakeholder needs or requirements. If not, another evolutionary round is initiated, and the process is repeated until a system is delivered to satisfied stakeholders or until the organization decides to terminate the effort. Most literature agrees that IID methods are best applied to smaller, less complex systems or to system elements. The focus is on flexibility and on allowing selected events to be taken out of sequence when the risk is acceptable. Tailoring in this way highlights the core activities of product development. Well, the features that distinguish IID from the sequential approaches are velocity and adaptability. While market strategies often emphasize that time to market or speed is critical, a more appropriate criterion is velocity, which considers direction in addition to speed. By incorporating the stakeholders into the working level teams, the project receives continuous feedback that they are going in a direction that satisfies the stakeholders' highest needs first. One downside is that reactive project management with a stakeholder that often changes direction can result in an unstable, chaotic project. On one hand, this approach avoids the loss of large investments in faulty assumptions. On the other hand, emphasis on a tactical viewpoint may generate short term or localized solution optimizations. IIDs may also be plan driven in nature when the requirements are known early in the life cycle, but the development of the functionality is performed incrementally to allow for the latest technology insertion or potential changes in needs or requirements. A specific IID methodology called evolutionary development is common in research and development environments. Below figure illustrates how this approach was used in the evolution of the tiles for the NASA Space Shuttle. An example of an incremental and iterative method is the Incremental Commitment Spiral Model, or ICSM. The ICSM builds on the strengths of current process models, such as early VMV concepts in the V model, concurrency concepts in the concurrent engineering model, lighter weight concepts in the agile and lean models, risk driven concepts in the spiral model or in 1996, the phases and anchor points in the rational unified processes, and recent extensions of the spiral model to address SOS capability acquisition. Well, a view of the ICSM is shown in below figure. In the ICSM, Each increment addresses requirements and solutions concurrently rather than sequentially. ICSM also considers products and processes, hardware, software, and human factors aspects, and business case analysis of alternative product configurations or product line investments, where the stakeholders consider the risks and risk mitigation plans and decide on a course of action. If the risks are acceptable and covered by risk mitigation plans, well, the project proceeds into the next spiral. Below figure presents another view of the ICSM. The top row of activities indicates that a number of system specs are being concurrently engineered at an increasing level of understanding, definition, and development. Conway's law suggests that organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. Systems thinking and SE help organizations avoid the pitfall of Conway's law by ensuring that system designs are appropriate to the problem being addressed. One of the earliest books on SE management identified three simple criteria for such organizations: facilitate communications, streamline controls, and simplify paperwork. The way to effective SE management is not in the direction of formal, formidable, massive documentation. It does, however, reside in the direction of creating a total environment which is conducive to the emergence and effective utilization of creative and inventive talents oriented toward achieving a system approach with a minimum of management encumbrances. Whenever someone, be it an individual or a company, wants to reach a desired end, they must perform a series of actions or operations. Further, they must consider the order of those actions, their dependencies, who will perform them, what they require, and what they will generate, how long it will take to complete them, and what tools they will employ. Thus, individuals and organizations follow processes, be they predefined or ad hoc, because process components like activities, products, agents, tools, and their interactions, for example, information flow, artifacts flow, control, communication, timing, dependencies, and concurrency, can vary. Processes will differ, even if the performing organizations have the same level, scope, and goal. So, why should an organization care about processes? In short, this is to better understand, evaluate, control, learn, communicate, improve, predict, and certify the work performed. For a given organizational level, the processes vary with the project's goals and available resources. At a high level, the company's business strategy determines the business approach, with the main goals of profitability, time to market, minimum cost, higher quality, and customer satisfaction setting the priorities. Similarly, the company's size, the number, knowledge, and experience of people, both engineers and support personnel, and hardware resources determine how to achieve those goals. The application domain and the corresponding system requirements, together with other constraints, form another important factor in defining and applying processes. So, what really is best for my organization? Well, the answer is that it depends on the situation. Depending on the perspective, different processes are defined for entire organizations, teams, or individuals. A one size fits all approach does not work when defining processes. Thus, organizations must continuously document, define, measure, analyze, assess, compare, and change processes to best meet project goals. One would hardly expect to find the same processes used in a startup e commerce company as in NASA. The intended goal shapes a process in terms of scope, namely the stages and activities covered, and organizational level. In any case, the selected processes should help guide people on what to do, how to divide and coordinate the work, and ensure effective communication. Coordination and communication, for example, form the main problems in large projects involving many people, especially in distributed projects where people cannot communicate face to face.